Introducing arithmetic sequences. So what is a arithmetic sequence? That is the difference between consecutive terms are the same. So let's say we have a sequence A1, A2, A3, A4, A5 to AN, and then keep on going. So if you look at the difference of the first two terms, A2 minus A1, that is equal to the difference of the second and the third term, A3 minus A2, which is equals to the difference is of between the fourth and the third term, A4 minus A3, which is also equal to the difference of the fifth and the fourth term, A5 minus A4, and then keep on going. So basically, you find the difference between A1 and A2 that applies to every two consecutive terms. So A1 and A2, so let's say the difference is 5, then the difference between 2 and 3 is 5, the difference between 3 and 4 is 5, and then so on and so forth. And then difference, what we call this a common difference. Now, if you prove that a sequence is a arithmetic sequence, how do you find the nth term? The nth term is equals to a of n, which is equals to the first term plus the number of term minus 1, and then multiply the difference. N is the number of terms. So for example, let's say we use even numbers, 2, 4, 6, 8, 10, 12, 14, 16. So what is the common difference between, what is the common difference? So the difference between 2 and 4 is 2. 4 to 6 is 2, 6 to 8, 8 to 10, 10 to 12, 12 to 14, 14 to 16. The common difference is always 2. So every time you go to the next number, you just add 2 to it, right? So the common difference D is the second term minus the first term, which is equals to 2. 2 is the common difference. This is the same as 6 minus 4, 8 minus 6, and 10 minus 8, so on and so forth. Now, as we keep on going, can you use one formula to represent the nth term, which is a of n equals to a1. This is the first term, so this is a1. This is a1, and then plus the number of term minus 1, and then multiply the common difference. So let's say you want to find the 100th term. You are not going to start at 2 and then add 2 100 times, right? That is going to take too long. So we will just use the formula n equals to 100, a of 100 equals to 2 plus 100 term minus 1 multiply 2, so that is equals to 100. That is equals to 200. Okay, now let's do some examples. So the first type of example is find the first 5 terms and then is the sequence arithmetic. I have 4 problems here. So how do we do this? So the first one is AN. Oh, you know what? I'm going to draw a line right here. Okay, AN, that is equals to 100 minus 3n. We need to write the terms out. So what happened when n equals to 1? When n is equals to 1, 100 minus 3 is 97. When n is equals to 2, 100 minus 6, 94. When n is equals to 3, 100 minus 9 is 91. When n is equals to 4, 100 minus 12, 88. When n is equals to 5, 100 minus 15 is 85. Okay, what is the difference? So from here to here, the difference is 94 minus 97, so negative 3, and then you subtract 3, and then you subtract 3, and then you subtract 3. Another way to read the a of n is you start at 100 and then you minus 3 as n increase by 1. So the common difference is 94 minus 97, which is equals to negative 3. And then this is a constant. Constant means every time you go to the next number, you subtract, or I should say you add the common difference. You add negative 3 means you subtract 3, right? The plus will take care, the minus will take care of the plus. So this is a yes, it is an arithmetic sequence. How about the next problem? The next problem is a of n equals to 1 plus n minus 1 and then times n. When n is equals to 1, we have 1. When n is 2, we have 3. When n is 3, we have 7. right? 2 times 3 is 6, 6 plus 1 is 7, and n is 4. 3 times 4 is 12, 12 plus 1, and then when n is 5, 20 plus 1 is 21. Okay, from here to here, here to there, so on and so forth. So this is supposed to be a 2, 3 minus 1, and then 7 minus 3, 4. Oh, uh-oh, failed. Should be 2, 2, 2, 2, 2, right? But this is a 4. This is a 6. This is a 8. No, the difference is not constant. So if this is an arithmetic sequence, it should go up 2 every single time. So this is not arithmetic. How about the next one? The next one is, I will write down the problems for you. Don't worry about that. So an equals to what? N minus negative 1 to the n. All right. So when n is equals to 1, we have to save some space for the next problem. When n is equals to 1, we have 1. We have 1 minus minus 1, which is a 2. When n is equals to 2, we have a 2 minus, we have a 2 minus, we have, wait, hold on, we have a 2. Negative 1 to the second power is, negative 1 to the second power is 1, so we have a 2 minus 1. When n is equals to 3, we have a 3 plus 1. When n is equals to 4, we have a 4 minus 1. When n is equals to 5, we have a 5 minus, we have a 5 plus 1, which is equals to 6. Negative 1, right? Plus, yes, 5 plus 1. So this is, how about the differences? This is a negative 1. Nope. This is a 3. This is a minus 1. This is a 3. No, this is not arithmetic. Okay, that is for the another type of example. I will do the last one right over here. The last one is what? The last one is a to the a of n. Save some space for the other example. 3 and then negative 1 to the n divided by n. When n is equals to 1, we have a negative 3 divided by 1. When n is equals to 2, we have 3 divided by 2. When n is 3, we have a 3 divided, we have a negative 3 divided by 3, which is negative 1. This is failed already. There is no way to go back and forth between negative and positive. So let's do the rest. This is a 3 divided by 4, and then this is negative 3 divided by 5. So look here. From negative to positive, do we agree that the common difference must be a plus? From positive to negative, the common difference must be negative. I don't need to know what that equals to exactly. All I need to know is you can't have one positive and one negative. So this failed immediately. So this is not arithmetic. All right, so let's go to the next type of problem. The next type of problem is find a formula for an, for the arithmetic sequence. So they already say that this is arithmetic. You just have to find the formula. All right, I can do that. So first of all, let's do this. A1 equals to 15 and then D equals to 4. We have to recall the formula. So recall, what's the formula? The an is equals to the first term and then plus the number of term minus 1, and then you multiply the common difference. So back to the first problem, the an that is equals to the first term, and then plus n minus 1, and then multiply the common difference. So all you have to do is you simplify this. 15 minus 4 is equals to 11, and then you plus 4n. That's it. And then the next problem, we have a1 equals to negative 4, and then a5 equals to 16. So a of n, that is equals to, can we just do that? Yep, we have the first term, right? So we have a negative 4, and then plus the number of term minus 1, and then multiply the common difference. Alright, so here is what I can do. I can erase this and then change that to a to the 5. So this becomes a 5, and then I'm going to let that equals to 16 because this is equals to 16. And then the common difference is right over here. And then all you have to do is you solve for d. So what is that equal to? That is equals to, you add 4 on both sides, that is equals to 20. This is 4d, and then the common difference is equals to 5. So the common difference is equals to 5. Now you can write the whole thing. So an that is equals to -4, and then plus n minus 1, and then you multiply by 5. So you have a -9, -4 minus 5, -9, and then plus 5n. All right. What about the last one? The last one, to save a little bit of space, I'm going to do some work over here. So the common difference from 10 to 5, you subtract 5, subtract 5, subtract 5, subtract 5. So the common difference is -5. And then the first term is 10. That's it. So the an, that is equals to the first term, and then plus the number of term minus 1, and then times the common difference. There you go, simple. An that is equals to 10 plus 5, 15, and then minus 5, and there we go. That is for the last one. And this is not the end of this video yet, because we have another example. So the next type of example is I want to write the first 5 term of the arithmetic sequence. The first problem is straightforward. The first term is 5, and then the common difference is -3/4. You don't need any formula. You already have everything you need. So the second term is 5. Because the arithmetic sequence, every consecutive terms have the same common difference, right? So all you have to do is you add the -3/4. You always add the common difference. If the common difference is negative, the minus will take care of the plus for you. So you always add the common difference. So this is 17/4, and then a3, you take the previous term, and then you add the common difference, that is equals to 14/4. It is good to not reduce the fraction, because you don't want to keep dealing with the common denominator. 14/4 plus -3/4, so that is 11/4, and then a of 5, that is 11/4 plus -3/4, so that is 11 minus 3 is equals to 8/4. So this is equals to 2. This is equals to 7/2. That's it. But things are not always that easy. The next problem, do you see that there is no common difference, and then you don't even have the first term at all? So in this situation, we have to recall the formula then, which is an equals to a1, and then plus n minus 1 times the common difference. So we have to summon the formula. And then let's see what else we can do. The fourth term, that means n equals to 4. a1, we don't know, it is okay. N is equals to 4 minus 1, common difference, we don't even know that too, but I know this is equals to 16. So that means a1 plus 3 times the common difference is equals to 16. That is not solvable, I know, but I have another equation. How about 10th term? That is a of 1 plus 10 minus 1 times the common difference equals to 46. So you have a1 plus 9d equals to 46. Do you see this, that we have two equations right here? Two equations. Each equation has two variables. You have learned how to solve a system of equation. What if I subtract them? Then a1 minus a1, subtract them. a1 minus a1 is gone. 3 minus 9 is equals to -6. And then 16 minus 46 is -30. As a result, d is equals to positive 5. Then there we go. Now I have the common difference. Okay, so now the common difference is out. How about the first term? So when d is equals to 5, all you have to do is you plug in 5 back to either one of the equations. So you have a1 plus 3 times 5 equals to 16. As a result, the first term is equals to 1. And then the next term is 1 plus 5, which is equals to 6. And then the third term, plus 5. And then the fourth term, plus 5. And then the next term, plus 5. And then we have 5 items, right? Oh, yeah, I can do one more for free. So the next term plus 5 is 26. And then you can keep on going. All right, so that is the end of the introduction to arithmetic sequence. If you like the way my introduction, you think this is the best way for you to learn math, please give my video a thumbs up, subscribe to my channel for more lessons like this. As always, I will meet you all in the future lesson. Signing out.